Hello everyone, welcome to BS Explained. I'm creating this video for a specific condition where you will have different flow conditions going to your individual chillers or any other equipment, maybe boilers, and then how to equate those flows. So I'm gonna overlay the actual condition that I'm talking, and then we'll go through the necessary programming steps that you have to take care so that we maintain the differential pressure, what you require, and then equate the flow for all the operating equipment. So for this condition, as you can see, I have considered 3 chillers and then 3 individual pumps for the chillers, which are pumping from the building, coming back, and then going back to the building. So what happens here is, in the condition where the chiller 1 is the active chiller running and this pump is pumping the flow this way, and if the building water is coming back here, so this gets the first suction pressure going back to the chiller here, and then if the chiller 2 comes on, even though the pumps are rated the same, the suction pressure being here might get an additional flow, not very on a higher margin, but maybe a little bit here and there with the tolerance. So you might, let's say if this pump is rated to 1300 GPM, this might be getting 1300, while this is also rated for 1300. This might be at the same speed getting maybe 1250 due to the suction pressure coming first to this and then to this. If the pipe was here and then distributing all together at once, I don't think it would have been the same condition that we're discussing, but in this particular condition you will see a flow difference between this to this and to this. So this might be much more lower than to this and to this, while all 3 are operating. Now, what we usually have in our control strategy is a differential pressure, which would be maintaining the control speed of all 3 pumps here to its set point based on all the balancing which has been done at your site. So what we're trying to do is, while all the pump speeds are trying to maintain a differential set point between the supply and return, we would be trying to equate the flow of all the chillers to a same flow value, so that your chiller 1, 2, and 3 would have the same efficiency while those 3 are running each other, right? So I'm gonna bring up my software to just to show you what we have done, or what I usually do in this case. So I have created 3 RAMs, which is like generating values to a base of 1250, going above 50 and below 50, which in fact would be ranging from 1200 to 1300, so that my chiller flow would be substantially changing. The same way, I have all these 3 ramps just generating random numbers between 1200 to 1300. I have this as an average of these 3 and a chiller flow average, which would give me my set point of what all 3 chiller has to maintain as an average. And then we have this equation here, differential pressure flow control, to which I have another ramp which is doing 0.5 offset of, or 0.5 amplitude with the base of 10, which originally equates to a triangle wave going from 9.5 to 10.5 for me to simulate this PID loop for the speed command of the pumps. So what we have done is, this chiller flow, average flow, would be the set point to my 3 PIDs for 3 chiller flows here, which would be giving out of how much higher, how much lower this will have to ramp up or ramp down to equate to the same flow for all 3 chillers. Now, the only thing which you will have to do in this one probably is if our chillers are not running, you might have to add a chiller status here in your PID enable, saying, hey, this PID only gets enabled only if the chillers are running. And then likewise, even for the average, you could do the same. So all those nitty gritties you can consider, but the major picture just which I wanted to imply on this creating this logic is this speed command, which is controlling the differential pressure, will be added with this PID logic, which would equate to a pump speed, which would not be the same. As you can see, pump 1 is 27, pump 2 is 27.4, but pump 3 is 0 because your flow is all changing up and down. So pump 3 is the highest, 1289, so pump 3 is at a reduced speed, pump 2 is reduced speed because this is higher than this one right now. So this logic is what you need to do. Now, just going into the deep of the logic, so this differential pressure is nothing but your set point maintaining its pressure of the PID, which is giving you an output of the speed command for the pumps. Now what I've done here to equate is this PID is taking one single chiller flow to its average flow of all three chillers into consideration and giving out output saying, hey, this should be like 50% more, whatever your PID has to be or will be tuned to. I haven't tuned any of these PIDs, so you'll see erratic behavior of this just going 0 to 100 and 100 to 0 all on its own. Then what I've done of this PID is you use a reset block in which you scale this PID output saying, hey, when this goes to 0 to 100, how much do I need? So what I've done is for the input of 0 to 100, I'm scaling this between minus 25 to plus 25 degree or plus 25% of output. What it does is if your PID output goes to 100, this will say you need to go 25% more than what you're doing in this current speed so that you equate this average flow to this flow. You will think this would be fighting it out, but when you see the flow not this erratic, when you actually tune the PIDs, the difference between these three flows would not be much higher, and the reset would not be more than likely well within the 10% of what we have to do, plus or minus 10. So you won't see an actual 25 or 25% more than what it is to ramp up of one pump to another pump. But I had to just do this because to you guys to visualize of what we're doing. So if you see from all the flows which are getting generated, you're seeing a minus 25 of this PID, plus 25 of this PID, and another plus, or you can see just modulating according to what the flow is doing, which adds up with this speed to this speed to give out an actual pump speed. Now I have used a limiter here which would limit a minimum of 0 and maximum of 0. Since we're adding and subtracting, you don't want minus 25 pump speed or 125 pump speed going to your VFDs. So we've used a limiter to limit your output 0 to 100. It won't go maximum of 100 and minimum of 0 in this thing. By this, once all the PIDs are tuned and it is stabilized enough, you will have this condition with this logic saying, even though all three pumps are running, even if it is doing 1300 of the pumps, when let's say you want to do 1300, all three pumps would do 1300, not irrespective of the suction pressure going here. So this to achieve 1300 at the rated might be doing at 50 hertz, this might be doing at 52 hertz, and this might probably doing at 54 hertz. But all three would be giving the chillers of 1300 GPM for better efficiency of three chillers to work which in turn would help you in energy efficiency and then conservation. So let me know. I would be adding this or creating this as a BOF file and then giving it out. Hopefully I will be uploading this onto a website or probably somewhere where you can access it. Let me know what you guys want to see next. Hopefully this helps. Thank you.